Hello. In this video, we are going to discuss how to write a Verilog code for a SR flip-flop and its simulation in Model Sim. So here we have written a module and the module name is given as SRFF and the flip-flop is having two outputs Q and QB and having the inputs S, R and clock. And it's a positive edge triggered flip-flop. So we use the statement pass edge clock in the sensitivity list for controlling the always execution. And straight away, the behavior of the SR flip-flop is depicted here in the case statements. So since we get the want output properly, so we have just rearranged these combinations 0 0 0 1 1 0 1 1, and that's the exact replica of the truth table. 1 0 means q will be 1 and 0 1 means q will be 0 and 0 0 means q will be q and 1 1 means it is undetermined, it's unknown state that we have defined here. And for the immediate update on qb, so it is defined outside the always block here, and that gives basically the SR flip-flop Verilog code. Now that is compiled here, and now we are going to run this. So here we have the list of signals for SR flip-flop, and that I added to the wave. And as I add it to the wave, and I make for my conveniently, I move these signals S, R, and clock to the top. Then S I'm setting with the value 100 clock value 100 time period and it's of rising edge. And similarly now I set the clock value for R, and then I make it as around 50, and I'm now will make it as a falling edge. So that's a falling edge. Then for a clock I set a time period of 25 and let it be in a rising edge. So now we are going to run this code. So as we run this code, we will be able to see the responses. So initially, the clock is 1 and S is 1, R is 0, and Q will be 1 and Q bar will be 0. Then using this icon, I move it to the next positive edge on the clock. So I have to select the clock here. So I select a clock here and I move it. Now exactly the positive edge it moves. Now with the positive edge, the S is 1, R is 1, and now the Q is unknown. So Q is unknown for uh, 1 1 combination, and also the Q bar is also unknown. Then we go for the next combination where it is 0 0, and at the positive edge when it's 0 0, and output will be of the previous state only. So that's what that unknown is continuing here. And when you go to the next positive edge, it's going to be 0 1. So the q is now changing it to 0. So then q bar will be set to 1 as a complement value. So that gives the performance of SR flip-flop. Thank you.